Hello and welcome to Maths 3. Firstly, pause the video here and go and do your daily arithmetic task, please. Okay, in this lesson we are going to be looking at adding and subtracting fractions still, but we are going to introduce mixed number and improper fractions as well. Okay, so a couple of things for you to have a think about here. This was covered in previous week's lessons. I know that some of you may have missed them. So, firstly, what are mixed number and improper fractions? It's really important that we understand what these two terms mean. Okay, a mixed number looks something like this. 2 and a quarter. And what it is really important that I understand. So as I just fix my screen now, what is really important that I understand is that is 2 whole ones and a quarter. Okay, so if that number, the bigger number, that is equal to 2. Now obviously sometimes when we type these out, they look nicely like this and the fraction is smaller, but sometimes it might look like this: 3 and a third. Okay, always a space between the whole number, which is 3, and 1/3. Okay, in this task you are going to have to work out whether it's a mixed number, and it's not 31/3, it's 3 and a third. Okay, improper fractions are just fractions which look like this. Okay, it's any fraction where the numerator is greater than the denominator. Okay, these are also fractions that are greater than 1. Okay, let's take for example 7 halves. If I had 7 halves, so say I've got a whole one there, it's split into 2 halves, another whole one there, that's 4 halves in total. So 2 whole ones is equal to 4 halves, 3 whole ones, look, is equal to 6 halves, and then I've got another half there. So I've got 7, 1, 2, 3, 4, 5, 6, 7 halves. So I could write that out as 7 halves, or I could write it out as 3 whole ones and a half. Okay, 3 and a half. So there is a relationship between mixed number and improper fractions. Sometimes you might need to convert from one to the other. So let's spend a little bit of time working out, or just we've done this already, but just reminding ourselves how to do it. Okay, so let's start by converting a mixed number into an improper fraction. Okay, so let's have 4 and a third, a mixed number. Converting it to an improper fraction, what I need to do is keep the denominator part of the fraction the same. So I want to know how many thirds are in 4 and a third. Okay, well, I know that 3/3 is equal to 1, and I've got 4 lots of 1. So what I need to do is do the whole number multiplied by the denominator. 4 times 3 is 12. And then add on the thirds that I already had. So that will give me the answer 13 thirds. Now, there was some revision materials on this in last week's maths lessons. I would very much advise, if you're not confident with the process of how to do this, going back and revising those, because it is going to be important. Okay, but the long and the short of it is, when I have a mixed number, for example 5 and a half, to convert it to an improper fraction, I keep the denominator the same. I do the whole number times the denominator. I add on the original bit. And now I can tell that 5 and a half is equal to 11 halves. In the same way, I might be asked to convert back the other way. Okay, so I might have 7 quarters. Now I'm going to teach you a shortcut of how to do this. What I'm going to do is I'm going to do 7 divided by 4. Okay, so that is an equivalent calculation. 7 quarters is equal to 7 into 4. Okay, so how many times is 4 going to 7? It goes in 1 with 3 remainder. That remainder can be expressed as a number over what I was dividing by. Okay, those two are the same. Let me show you that again. Let's have 11 halves. Okay, so to work this out, I'm going to do 11 divided by 2. How many times is 2 going to 11? Well, it goes in 5 times with 1 remainder. So that is a half. I put the remainder as a fraction over the denominator, which was the number I was dividing by, 5 and a half. Okay, so that is a shortcut for doing those. Again, all of that revision material is available for you from last week's lessons. Again, as always, pause here, check you are comfortable with the star words. Adding with mixed numbers first. Okay, so I might be asked to add 2 lots of mixed numbers. So what we're going to do is keep it so the denominators are the same for the first bit. So 2 and a quarter, add 5 and a quarter. Well, let's have 5 and 2 quarters. So I add a question like this. Okay, this is about as easy as it's going to get for this lot. When I'm adding 2 mixed numbers together, firstly, I add the whole numbers first. 2 add 5 is 7. I'm done with those. Now I need to do a quarter add 2 quarters. Well, I can see from previous lessons that because I know the denominators are the same, it will stay the same in the answer. So I've got 1 quarter here, I've got 2 quarters there, add them together, 3 quarters. If I get a question like that, nice and straightforward, add the whole parts first, add the denominators after. What I might get, however, is I might get a problem where the denominators are not the same. For example, I might have 3 and a third, add 4 and a sixth. If I do get a problem like that, I need to, again, always add the whole numbers together first. 3 add 4, 7. Then I need to do what I did in the last lesson. What I'm doing is I'm doing a third add a sixth. I need to convert the third into sixths. So how many sixths is that? Well, to get from 3 to 6, I had to multiply by 2. So I'm going to do the same to the top. So now I'm adding 2 sixths and 1 sixth together, which is 3 sixths. Don't worry about simplifying fractions or anything at all. Exactly the same sort of thing if I'm subtracting with mixed number. Okay, I might have 4 and an eighth, subtract 2 and an eighth. So I'm going to deal with my whole numbers first. 4 subtract 2 is 2. 1/8 subtract an eighth is no eighths. Okay, we could just leave the answer as 2, or we could write 2 and no eighths. Let's do another one. 5 and 3 quarters, subtract 1 and a quarter. Denominator is the same again. 5 subtract 1, dealing with the whole numbers first. Remember, 5 subtract 1 is 4. 3 quarters, subtract 1 quarter, 2 quarters. Remember, because the denominators are the same, it stays the same in the answer. All I'm doing is 3 subtract 1, which is equal to 2. Adding then with improper fractions. This is easy, easy peasy, okay? If I had, for example, 11 sevenths, add 14 sevenths, I can see that my denominators are the same. It's going to stay the same in the answer. 11 add 14, 25. The question has just asked me to add them together. If it asks you, sometimes you might get a question that says, then convert it to a mixed number or something like that. These questions aren't asking you to do that. They're just asking you to add these improper fractions. What would I do though if my improper fractions had different denominators? What would I do? Well, I know that I need to convert one of them, don't I? I look at the one with the smaller denominator, which is 2/5, and I need to convert that to a number of tenths. So, from 5 to get to 10, I multiply by 2, so I do the same to the top there. So now I know that I'm doing 5 tenths, add 4 tenths. The denominator stays the same. I add the numerators together, 9 tenths. What about subtracting? Well, good news is it's exactly the same level of ease. If I had 7 quarters, subtract 5 quarters, I can see that the denominators are the same. So they're going to stay the same in the answer. So what I'm doing is 7 subtract 5, which is 2. 2 quarters. Don't need to convert, don't need to simplify, leave the answer as it is. Exactly the same if I had 7 halves, subtract, say, 5 quarters again. I can see that I need to convert one of these. Which one am I going to convert? Well done if you identify. It's always easier to convert the one with the smaller denominator first. So 7 halves I want to express as a number of quarters. From 2 to get to 4, I multiply by 2. So from 7 multiplied by 2, 14. So what I'm doing now is 14 quarters, which was equal to 7 halves, wasn't it? Subtract 5 quarters. Denominators are the same, so they can stay the same in the answer. 14 subtract 5 is 9. What I want you to do now, please, is pause and practice what you have learned so far. Okay, welcome back. I hope that you feel free to refer back to the video, rewind at any point. I'm not sure how easy that is for all of us because we're on different devices and things like that. I'm hoping you are able to rewind the video to find the relevant points. Let's go through what we have here. These are the types of questions that are going to be in your independent task, okay? So, firstly, we've got 2 3/4, add 1 1/4. What do I need to do first? I need to add the whole numbers. 2 add 1 equals 3. I'm done with those. They're added together. They're on the other side of my equality sign. They're done. Now I have 3/4 here and 1/4 here. I can see my denominators are the same. They're going to stay the same in the answer. Add my numerators together. 3 add 1 equal to 4. Now, I do know that 4/4 is equal to 1, so I've got 3 and 4/4, which is actually equal to 4. But for our purposes, just for this lesson, it's absolutely fine to give an answer like that. Okay, we'll worry more about converting to the best form of the answer a bit later on in the year. Okay, for now, an answer like 3 4/4, that's absolutely fine. Let's move on to the next one then. 5 9/10, subtract 2 5/10. So I start with the whole number part. This is where it can be a little bit tricky to see that this is a mixed number still, but I've tried to make that very clear in the questions, okay, on the independent task. So I'm going to start with the whole number bit. 5 subtract 2 is 3. Done with those. All good. I've got 9/10 here, and I want to subtract 5/10. Well, the denominator is the same, so it will stay the same in the answer. 9 subtract 5 is equal to 4. Moving on then to improper fractions, I can identify that these improper fractions have the same denominator. So the denominator can stay the same in the answer. Now I need to add on the numerators together. 23 add 11 is 34. Let's move on to the last one then. I am subtracting improper fractions. Well, I can see that the denominator is the same, so it's going to stay the same in the answer. I'm doing 45 subtract 18. Well, I know that 45 subtract 20 is 25. Add the 2 back on, 27. If you need to get out a piece of pen and paper or whatever to work out the subtraction part of the problem, that of course is absolutely fine. Whatever way you get to the correct answer. The only complicated bit that we are going to get is when we have a combination of mixed number and improper fraction in the question. Okay, what we need to first do is convert. Now, my advice to you, it's generally easier to convert the mixed number into an improper fraction using the step-by-step process that I gave you in the previous lessons and at the beginning of this video. Okay, so you've got twice for it to refer to. I'm going to give it to you a third time now. 2 3/4. I'm going to convert to an improper fraction first. Okay, so I've got 2 3/4. My step-by-step process. My denominator stays the same. I multiply the whole number by the denominator. 2 multiplied by 4 is 8. And then I add on the fraction bit that I already had. 8/4 add 3/4 is equal to 11/4. So this calculation now is 11/4 add 7/4. Can I easily add these together? Well, yes, I can. Denominator is the same, stays the same in the answer. 11 add 7, 18. My answer is 18/4. If the question doesn't ask you to convert back to a mixed number or anything like that, just leave the answer like that. You don't, just because the question has a mixed number and an improper fraction in it, your answer can just be either, unless the question specifically asks you for one or the other. What about then if it's a mixed number and an improper fraction and the denominators aren't the same? This is as challenging as this is going to get. Okay, so first thing I'm going to do is convert the mixed number into an improper fraction. Okay, so I have 4 3/4. You should know the step-by-step now. Step 1, I keep the denominator the same. Step 2, I do the denominator multiplied by the whole number. 4 multiplied by 4, 16. Then I add on what I originally had. 16/4 add 3/4 is equal to 19/4. Now, my question is asking me to do something add 8. So let's convert. So now what my question is asking me is, what is 19/4 add 11/8? Well, now what I'm doing is I have a problem like the ones I had yesterday, where I've got two fractions with different denominators that I want to add together. So what I need to do is convert the fraction with the smallest denominator, so it has the same denominator as the other fraction. So I'm going to convert 19/4. I'm going to tell me how many eighths it is. Well, what did I do from 4 to get to 8? I multiplied by 2. So what do I have to do to 19? I have to multiply it by 2 to give me the answer 38. So now I have the question 38 eighths add 11/8. Denominators are the same, so they stay the same. 38 add 11 is 49. My answer to this tricky problem is 49/8. As you can see, lots of maths involved in that type of question. So here is what you are going to do for your independent task. Okay, let's go and have a look at the independent task. The first question is asking me to add and subtract mixed numbers. Okay, all of the questions in challenge 1 are mixed number. So you can see that for the most part, the denominators are the same. If they're not the same, they are multiples of each other. Okay, obviously feel free to go back and watch the necessary bit of the video if you need to remember how to convert things. Okay, it's just 6 questions for you to answer there. Challenge 2, we are adding and subtracting improper fractions. Okay, this is easier. The only time it gets difficult is like in question 6, where I have to convert one of them first, because I can't just add 9/4 and 1/12. I have to convert 9/4 first into a number of 12s. The last one is adding and subtracting a combination of mixed number and improper fractions. This is going to help you, this step-by-step task here. Okay, what you need to do is convert the mixed number first into an improper fraction, which I've given you an explanation of how to do that there. Then you add on the improper fraction, making sure that the denominator is the same. If the denominators aren't the same, then you'll need to convert them so they have the same denominator, and then you're going to add or subtract them. So 3 stages to your independent task there. Have fun with them, and goodbye.